Okay, so you've learned about arithmetic. You can take any numbers, put them together, and you've learned about variables and formulas. Well, now we're going to put them together to really find the power of algebra. So, for example, we did 3 plus 7. You were able to say, okay, 3 plus 7 equals 10. 3 plus 7 equals 10. You can put those numbers together. You become very good at that. Algebra, we start doing this sort of a thing. 3 plus what equals 17? And we start to run into, okay, whoa, I'm not taking the 3 and the 17 and putting them together anymore. I'm saying, let's go backwards. Here's something that I started with that I don't know what it is, but 3 plus what equals 17? Now, we learned before that whenever you have something that you need to represent, but you don't know what it is yet, it could be any amount of numbers. That's a variable, and that's where it comes in. So we write this as 3 plus a number, n, pick a letter, equals 17. And you're like, oh, hey, that number, that must be a 14 in order for it to work. So let's play a little game. I'm going to start out with a number. I don't know what it is yet. I'm going to call it P. I'm going to take that number, and I'm going to add 5 to it, and then I'm going to times by 4, and I equal 32. And your challenge is to find the number I started with. Take a minute. P plus 5 times that whole thing by 4, and I get 32. Well, if you start working backwards, you're like, okay, we have 32. Something times 4 was 32. So really, if you go backwards on that, 32 divided by 4, I must have had the number 8 right here. 8 times 4 is 32. And I did that by going backwards on that guy, by dividing by 4, kind of undoing it. Then, a number plus 5 is 8. If I go backwards again, 8, subtract 5, that number was 3. You can see what would happen. 3 plus 5 gave me 8 times 4 is 32. We're able to kind of work backwards. So we have this idea of undoing stuff that was done. And you'll see over here, when we have an equals sign, we have kind of a balance. An equals sign says that whatever is on this side and whatever is on that side are exactly the same thing. You have a balance. Here's this side, here's that side, they are exactly the same thing. Well, I want to know what this number is. And so we're like, this number plus 3 equals 17. We can take that 3 away if we take 3 away from the exact same side. On a picture, it would look something like this. Here's our little balance. Cute little picture like that. Here is a little 3, and here is something we don't know what it is yet, n. And over here we have something that is, weighs 17. And what we can do is say, if we want to know what n is, take 3 there and take a 3 there and just take it off. As long as we do it to both sides, it stays balanced, and now we have the n must be a 14. So we have two major ideas that are going on here. Number one, you want to peel off by going backwards. Number two, you want to make sure you keep everything balanced. I'll show you how handy this can be. We're going to take a larger equation. If I took a number, times it by 2, and added 7, and on that number I get 11. 2 times the number plus 7 gives me 11. We're going to go backwards and find out exactly what that is. So in this case, we want to go backwards and get rid of that. So we subtract 7. Get rid of that positive 7. We have 2x equals 4. Now, 2 times the number equals 4. So we undo, peel off this 2 by going backwards on it. Backwards of multiplication is division. So we divide, and we now have x equals 2. Let's do another one kind of like that. 3 times the number plus 18 equals 5. Ooh, give that one a try. See if you can do that. 3 times the number m, we don't know what the number is, plus 18 equals 5. You notice we're going backwards. You're not taking the 3 and the 18 and the 5 and combining them like we did in arithmetic. We're going backwards to see what we started. So right here, we want to get rid of that positive 18. So we subtract 18 from both sides. So we have 3m equals a negative 13. 3 times what equals negative 13? You may not be able to know that exactly. 3 times what? I don't know either. So we divide right here. Divide by 3 and divide by 3. You get that this number is going to be a negative 13 thirds. And there we have it. Negative 13 thirds was our number. Didn't turn out nice, but at least it's there. We got it. Let's make a bigger one. 5x minus 1 divided by 3 equals 7. Ooh. We've got a little bit bigger problem. What are we going to do here? We want to get rid of the 3 first, then the 1, then the 5. And in fact, there's kind of a food analogy that's pretty good here. I don't know if you guys have ever eaten one of these. I'm going to try to draw it. It's an artichoke. There's the artichoke heart that is apparently the best thing to eat. You can boil them, steam them, kind of nice. But you eat them by peeling off the outside leaves first. You can't peel off the inside of the leaf. That'd be kind of silly. You can't start from the center. You peel it off from the outside. And that's kind of what's going on. Here's the center. That's what we want to get to. We want to find out what that guy is. And we use this concept of a balance to get there. You'll notice the first thing by our order of operations that x hits is the 5. The negative 1 is the second thing. And then the bottom one, this 3, is the third thing. We're going to peel that off in reverse order. Here we have a divide by 3. How do we go backwards on divide by 3? We have to times by 3. That's the opposite. That's what undoes multiplication, is division. So divide by 3 times by 3, it's gone. As long as we do this to both sides, then we have the balance. So the 3's gone here, and that's a 21. So we have 5x minus 1 equals 21. Now we've got to get rid of this minus 1. Opposite of minus 1, plus 1. So we add 1 here, keep it balanced. And you see this problem was huge to begin with, and slowly it gets smaller and smaller until we'll have just the x left. So now we divide by 5, we have x equals 22 fifths. Now if you wanted to use your calculator, you have 22 divided by 5, and you get 4.4. Either one of these is perfectly acceptable as an answer. Let's do one more about that size. Negative 2x plus 3 over 8 equals 5. Let's see what we get with this one. So again, we have 3 things that we need to get rid of. We have the 8 and the 3 and the negative 2 to get rid of in some way. This is a divide by 8, so we have to get rid of it by timesing by 8. As long as we do it to both sides, keep that balanced until we can get x down by itself. So the 8's are now gone. So we have a negative 2x plus 3 equals 40. Now, get rid of that 3. Minus the 3, minus the 3. Have a negative 2x equals 37. Oh, yuck. That doesn't look very nice. You're like, negative 2 times what equals 37? Well, that's why this is so valuable. There's a number there that does this. We don't know exactly what it is. We can find it by getting rid of this negative 2. Now, you might think, well, it's a minus 2, so we add 2 to both sides. I want you to think back to this. We're not looking just at the negative 2, but how it is attached to the x. And this is attached. These are right next to each other, so that's a multiplication right there. So we have to get rid of it by dividing by the negative 2. If we just add 2 to it, it's not going to break the multiplication. So we have x equals 37 over negative 2. You can either write it like this, or what is that? Negative 18.5. Either one. That's what our number there is. This kind of process, just one piece at a time, can get bigger and bigger and bigger. We're going to do a big problem now. If I were you, I would write this down. 2q plus 1 divided by 3 plus 5 times 4 is 48. This looks like an enormously bad, ugly problem. But it's just peeling off one at a time. If you can do it once, twice, 3 times, why not get rid of the 2, the 1, the 3, the 5, the 4? Now here we look, and the q, the first number it hits is that 2. The second is right here. The third is right there. Then because of these parentheses, that's the fourth one. And the fifth one, we've kind of created this artichoke, or if you will, an onion, where you've got the center, the x, and everything's piled all around it, and we've got to get rid of those. So this is what we're going to do. Peel it off from the outside in. How do we get rid of that 4? Well, it's attached by multiplication. So we undo it with division. We're going to divide this whole side by 4 and this whole side by 4. Those are now gone. We just peeled off that level. This side is a 12. So we now have 2q plus 1 over 3 plus 5 equals 12. You can kind of see by our numbering up here, we've got to get rid of that plus 5. Opposite of adding 5 is subtracting 5. So we now have 2q plus 1 over 3 equals 7. And we've just sort of whittled this problem down. Now you should note about this time that if you have always desired to number your paper from 1 to 30 and get all of the problems on the same line, it's not going to fit. Don't try it. How do we get rid of the divide by 3? Times by 3. Good answer. So we have, this is now gone. 2q plus 1 has to equal 21. So how do we get rid of this plus 1? We subtract 1. And so we get 2q equals 20. Get rid of the 2, multiplication. Divide that 2 off. It's the opposite of multiplication. And we get q equals 10. Marvelous. Now, you get done with a problem like this and you think, aha, we got the answer. Q equals 10. That's wonderful. So what? It's a great question. Right now, we're exercising the ability to take this equation and these two principles, peeling off by going backwards, and balancing the thing all the time using that balance. We can add and subtract, multiply or divide anything we want to both sides. We're able to find this number. Now right here, this is just kind of a riddle. If I were to say this in English, I would say, I started with a number. I first times it by 2. Then I added 1. Then I divided by 3. Then I added 5. Then I times by 4. And I ended up with the number 48. Guess what I started with? Well, I think people just got really tired of guessing. And so they started figuring out a way to actually find the number by going backwards. And this is what it is. If you start with 10, try it. 2 times 10 is 20. Plus 1 is 21. Divided by 3 is 7. Plus 5 would be 12. 12 times 4 gives you 48. That's how you can always check your answer, by sticking that number you got back up in there like the formula.
To the boards! Hello and welcome back to the boards. We're working on these 4 questions on how to solve equations. There is a 3-step procedure on these that we have learned. First, you need to peel off by going backwards through the problem. Once you identify the part that is furthest away from the x, you're going to undo it on both sides. So if it's plus, you're going to undo it using subtraction. If it's multiplication, you're going to undo it using division. And then you're going to repeat over and over again until x is by itself. So let's have you give it a try. Take out your video notebook and work on these 4 problems. When you're ready to check your answers, go ahead and unpause the video and we'll work on it together. Good luck! Okay, question number 1. 8x plus 1 equals 17. We need to get x by itself. Step number 1, we need to peel off by going backwards. So the most backward part is the plus 1. So we need to undo it using the opposite of plus 1. We're going to do minus 1 to both sides. When we do that, we're left with 8x equals, and 17 minus 1 is 16. Now let's repeat. What's the next part that we've got to get rid of? We need to undo the times by 8. So to undo times by 8, we're going to divide by 8 to both sides. When we do that, we get 16 divided by 8. 16 divided by 8 is 2. And notice the x's cancel out, just leaving us with x. So our answer is x equals 2. Okay, let's work on question number 2 here and see if we can do the same thing. Step number 1 is to peel off by going backwards. So we need to get x by itself. The thing that we need to peel off first is this divide by 5. We're trying to get x by itself. We need to undo the divide by 5. So to undo it, we're going to do the opposite operation. So the opposite of divide by 5 is times by 5. So we'll times both sides by 5. We'll be left with negative 2x plus 4 because these 5's cancel out. And on the other side, we get 6 times 5, which is 30. So we're still trying to get x by itself. We now need to find the next part that we need to peel off. We're going to peel off this plus 4. So we're going to do the opposite operation to both sides. The opposite of plus 4 is minus 4. So we'll minus 4 to both sides. Notice that the plus 4 and minus 4 cancel out, and we're just left with negative 2x equals 26. Repeat! We'll come back up here. We need to peel off again. To get x by itself, we're going to peel off a negative 2. So the opposite of times by negative 2 is divide by negative 2. So we'll divide both sides by negative 2, leaving us with x equals negative 13. That's our answer for number 2. Let's take a look at number 3. Again, we're going to need to start by peeling off. We got to get this x by itself. We've got a lot to peel off here. We're going to start by peeling off the times by 2. So to undo times by 2, we divide by 2. That leaves us x plus 1 over 3 minus 1 equals 4. Repeat! We got to peel off the next part by going backwards. Let's see, we're going backwards to the x. So the opposite of minus 1, that's what we got to do next. So we're going to undo the minus 1 by doing plus 1 to both sides. When we do that, we get x plus 1 equals 3, or x plus 1 over 3 equals 5. Repeat! We now need to undo the divide by 3. So to undo divide by 3, we multiply both sides by 3. Remember, we always do it to both sides to keep it balanced. Here the 3's cancel out, and we're just left with x plus 1 equals 15. Repeat! Now what are we going to peel off? We got to peel off the plus 1. We'll do it by doing the opposite to both sides. Opposite of plus 1 is minus 1. So we minus 1 to both sides, and we get our final answer of x equals 14. Nice work. Now on number 4. This one's a little tricky because we've got 4x and 3x. Ooh. So when you've got multiple x's, it's important that we combine the like terms first. We could even include that as like a step 0. We could say, hey, combine like terms. So that's what I'm going to do here. I've got 4x plus 3x. That's 7x minus 1 equals negative 8. Now let's peel off the first thing. The first thing we got to peel off is this minus 1. Opposite of minus 1 is plus 1. We'll do that to both sides. We're left with 7x equals negative 7. We got to get x by itself, so we're going to peel off this times by 7. We'll do that by dividing both sides by 7. And so our final answer is x equals negative 1. Nice work at the boards. Keep working hard, and we'll see you next time we need some practice.
Now, we all have had a chance to work with formulas now, put them in Excel, stuff like that. And so, you now have an opportunity to take those formulas that you have learned. For example, we did this one. If you have a rectangle, and here's the width, and here's the length, you've done problems where we said, okay, find the perimeter if the length is 7 and the width is 8. You were able to stick them in here and do arithmetic to find out what they were. Now we're going to change that a little bit and say, okay, what if I give you the perimeter and the width, and you have to go backwards and find what the length is. Here's how we do it. Let's say the perimeter is 44 inches, and the length is 9. No, the length is 13. And we want to know what the width is. Well, you can stick these in right now. So you have a 44 equals 2 times 13 plus 2 times w. That means we have 44 equals 26 plus 2w. Now what we've just got here is one of those equations that we can solve without very much problem at all. We have 2w plus 26 equals 44. If we want to get that w by itself, we're going to do it. Subtract this 26 off. And we get 2w equals, as these are gone, 44 minus 26 should be 18. And how do we get rid of that 2? 2 times w, we're going to divide. So we get w equals 9. So the width of this is 9. Now we can do that all the time, but this actually allows us to create more formulas. I know you're probably excited about that, jumping for joy, but it actually becomes kind of nice to take the formula and say, you know what? Could we make a formula where we had w by itself and the perimeter and the length on the other side? And you can. We're going to do the same process, but assume that we don't know this. Can we still solve for that formula and get w by itself? Here's how we do it. Here's our center of what we want to solve for. And it would say something like, solve for w. So here's w. You want to solve for it. So we've got to get rid of this number that's kind of glued together with multiplication. So we're going to subtract it off. Now, the nice thing about this is the p and the 2l, not a like term. Can't combine them, so you just write p minus 2l. All right. That must equal 2w. Now, we're trying to get w by itself, so how do we do that? We've got to divide by 2. And there we have it. We have w all by itself, and we have a whole other formula. It doesn't look like an answer, but when they say solve for w, solve for one of the variables, you're just creating a formula with this guy all by itself, and the other one's there. In particular, we had one where we did the following. Celsius equals 5/9 Fahrenheit minus 32 degrees. We were able to change back, well, not back and forth. We were able to change from Fahrenheit, if we had a Fahrenheit number, stick it in right there, and it would pop out a Celsius number. But try going backwards. Stick in a Celsius number and finding out what the Fahrenheit is. It's a little bit trickier. You'd have to stick in a number here. You could do it. And then you'd have to solve and peel off all of these things. Well, we can do that and get a formula for that. So if you look, here's Fahrenheit. Here's the center of our little artichoke. First thing it hits is this minus 32. And the next thing it hits is timesing this 5/9. So if we want to undo and get rid of this, timesing by 5/9, we could divide by 5/9. Boy, does that look bad. So now the test is, do you remember how to divide fractions? Dividing fractions, we don't really know how to do it. We times by the reciprocal, flipping it upside down. So really, this is c times 9/5 is what this really turns out to be. So let me write that all down. We have 9/5 times c equals, now we have f minus 32. And how do we get rid of the 32 to get the f by itself? Add 32. And we have a formula where now we can go back to Fahrenheit from Celsius. So if you were to have a Celsius, you could stick it right here, times by 9/5, and then add 32 to it, and it'll give you the Fahrenheit. That's how we solve for formulas. We're able to do that.
Hello and welcome back to the boards. It's time for you to practice some solving formula questions. We're going to use the same three-step procedure that we used in the last section. First step, peel off by going backwards. Find the outside operation and then undo it by doing the opposite to both sides of the equation. And then repeat until you get the variable by itself. Now, it might not be x. For example, in number 1, we're going to be looking for y. In number 2, we're going to be looking for k. And in number 3, we're going to be looking for h. So whatever letter they ask you to solve for, that's the one you're going to solve. So go ahead and pause the video now and try these 3 questions and solve these formulas for those given variables. When you're ready to check your answer, unpause it and we'll work on it together. Good luck. Okay, welcome back. Here we go. Question number 1. We need to get y by itself. Here's the y. So we need to look at the most outside operation. It looks like it's this plus ax. I need to do the opposite of plus ax. So I'm going to minus ax to both sides. Minus ax. When I do that, I'm going to be left with by, and that equals c minus ax. Now I'm trying to get y by itself, so I now need to peel off this times by b. The opposite of times by b is divide by b. So we would divide everything by b, and now my y would be by itself. And that means this is my answer. C minus ax all over b. Once your y is by itself, you're done. Okay, number 2. Number 2, we got to solve for k. Now, k is trapped right here. We got to get this k out. So let's work on peeling off the outer parts. So we're going to start by undoing a divide by z. The opposite of divide by z is multiply by z. So I'm going to multiply both sides of the equation by z. When I do that, over here the z's cancel out. I'm just left with 3k plus 2 equals wc. Okay, still trying to get k by itself, so I'm going to peel off this plus 2. The opposite of plus 2 is minus 2, so we'll be minusing 2 to both sides. Now I have 3k equals wz minus 2. Now I got to get the k by itself, so I'm going to peel off the times by 3. Opposite of times by 3 is divide by 3, so we'll divide everything by 3, and now k will be by itself. The answer is wz minus 2 over 3. Excellent. Okay, number 3. We got to solve for h. Got to get the h by itself. Okay, so let's work by peeling off the most outer thing. I'm going to peel off this times by 1/2. We got a times by 1/2 here. The opposite of times by 1/2 would be divide by 1/2. Now, dividing by a fraction, you can also just flip and multiply the fraction. So instead of dividing by 1/2, I'm just going to times by 2. I'm going to think of this as a divide by 2, and the opposite of divide by 2 is times by 2. So we'll multiply both sides by 2. So I'm left with 2a equals, here the 2's just cancel out, leaving me with bh. I'm trying to get h by itself, so now I've got this times by b. The opposite of times by b would be divide by b. So I'm going to divide both sides by b, and that is my final answer. H equals 2a all over b. Nice work solving these formulas. Keep working hard.